So hi everyone. In today's class, I'm just going to clear some of the confusion related to displacement. Okay. So I'm just writing the topic name, that is displacement, right? So in the class, we have learned that displacement, it is a vector quantity, right? So what do you mean by the meaning of this vector quantity? It should have a magnitude as well as a direction, right? But how to calculate the direction? If I just draw a diagram of the displacement of an object, suppose the object has started his journey in the north direction and it has covered 500 meters, okay, in the north. Then he just turned right and he had covered 400 meters, and now in the south direction he is covering only 200 meters, and then he stopped. He has reached the destination. So in this case, this is my starting point, or this you can see my initial position, and this is denoted as A, and here it is my final position, it is denoted as B. I have to find out the minimum distance between the initial point and this final point, or you can say the initial position and the final position. So the displacement should be found out by the minimum distance between the points A and B, and it will have a direction like that, right? So that's why we can say that the displacement is having a particular direction from A to B. I am measuring it, right? And in this case, I have just drawn a parallel line with respect to the above, that is this much is 400 meter, right? So we can say that if the total distance here, I mean that much of distance is 500 meter, and in the opposite side, if some distance covered in the south direction, that is of 200 meter, so obviously the rest of the distance will be 300 meter, right? So with the help of the Pythagoras theorem, we have find out the displacement between the points A and B, the initial point or the initial position, and B is the final point or the final position of our journey. So in this case, the answer we have obtained as 500 meter, right? So how to represent that? So in this case, I will write down that D and an arrow sign should be given, and that represent that it is a vector quantity, because with the help of this arrow sign we are able to show the direction from A to B. But I should not write down like D vector is equals to 500 meter. This is not the correct process, because whenever I'm writing down any of the vector, it should have a direction, and that meter word or any kind of SI unit should not be written there, right? So what is the actual procedure to represent a vector quantity? Though I will teach the chapter vector after the completion of this motion in one dimension, but I have to introduce some of the basic concept of this vector. Okay. So you have to learn one thing, that the displacement can be measured in one direction. Suppose I'm talking about x-axis, right? Along x-axis, if I am measuring the displacement, so in that case I will write down an unit vector that will work along the x-axis. What I mean by unit vector, it's a one type of vector that determines the direction of that particular quantity. Okay, there are three kind of unit vectors are. First unit vector, which walks along the x-axis, is known as I cap. Okay, this is the symbol cap, and this is I. Always be represented by the small letters. Okay. Now if I say that the object is moving along the y-axis, that means it is moving up. So the unit vector along the y-axis is represented as j cap. So if an object is moving along the x-axis, the unit vector is I cap, if the object is moving along the y-axis, it should be represented as j cap. So now we are talking about only one dimension, either x or y, right? So this is the y-axis that we are talking about. But if the object is moving in a plane, that means in a two-dimensional plane, where the x-axis and y-axis, both of the axes are present. This is our x-axis, this is our y-axis, okay? Now if the object is lying at this point, right? So we have to measure the position of the object, right? So in that case, the position can be measured with respect to the x-axis as well as with respect to the y-axis, right? So I can say that the position can be, suppose along the x-axis it has traveled a distance of 3 meter, and along the y-axis it has traveled a distance of 4 meter. Okay, so the position of that particular object should be represented as 3 I cap plus or 4 j cap. Now if the question asks you, now at this point you have to find out the displacement of the object. So in this case the starting point is the origin O, and from the origin at first the object has traveled along the x-axis up to 3 meter. Then along the y-axis it has traveled 4 meter, right? So the position is 3 I cap plus or 4 j cap. Now I need the displacement, that is the minimum distance between the starting point and the final point. That means the distance from the origin. How to find out that distance? It should have some value, 1, 2, 3, 4, 5, like that we need the value. So in that case, till that time we know the position vector of a particular object. It is represented as p vector. It is equals to 3 I cap plus or 4 j cap, right? So in this case we have to find out the displacement. To find out that, what we need to do, I need some value. I don't need this I cap j cap expression. So in this case I will find out the mod vector. Mod vector means modulus of the given vector. Okay, whenever you have to find out the distance of any object which is placed in a two-dimensional plane from the origin, so every time you have to find out the modulus of that particular position vector. Okay, so as the object is placed at some particular point in a two-dimensional plane and we have to find out the distance from the origin, I am taking the modulus. Modulus means what? It is equals to under root of coefficient of I cap, that whole square, plus of coefficient of j cap, that whole square. So it is equals to under root of 16 plus of 9. It is equals to under root of 25, and we are getting the answer as 5 meter. So in this way we are able to represent the displacement as 5 meter. Okay. Now in this case, why I had said that d vector equals to 500 meter is wrong, because whenever the vector sign is present, it should have some I cap, j cap, k cap. Now I have not told you about the k cap. Let me just tell you about the k cap. Now if we just consider a plane which is 3D in nature, that means it should have some x-axis, it will have the y-axis as well as z-axis. Okay, so along the x-axis the unit vector which is represented as I cap, along y-axis the unit vector is represented as j cap, along z-axis the unit vector represented as k cap. Okay, what is unit vector? I am just repeating the concept. Unit vector is a one type of vector quantity which is having a magnitude of 1. Magnitude means modulus of I cap is equals to modulus of j cap is equals to modulus of k cap, and it is equals to 1. So they have a magnitude of 1 and they just represent the direction of the given physical quantity, right? Suppose I am writing down the displacement of a particular object. It is represented as d vector. Along y-axis, the displacement is a 5 meter. Okay, along y-axis, the displacement is 5 meter. So how to represent that in vector form? Along y-axis, the unit vector will consider as j cap, and it will be represented as 5j cap. Okay, whenever you will find out the modulus of that particular quantity, that is modulus of d vector, it is equals to under root of coefficient of j cap, that whole square. This whole square and the root, they will cancel out, and I will get the final answer as 5 meter. Okay, that's the difference. So whenever you will just write it down that d vector equals to 500 meter, it is wrong. You should write modulus of d vector, it is equals to 500 meter, because in the given question they have not mentioned any kind of direction. Okay, in this case I'm just calculating like that, but it is not a question related to 2D plane or a 3D plane or anything. So we'll just write down modulus of d vector equals to 500 meter, because it has given us a value. Okay, so lot of things I have just told you. If you have any kind of confusion related to this small vector concept, you can tell me. I will repeat that in a live class, or I will make you understand. Okay, now the second part. Now in this one video I'm just telling you some of the concepts which are very much needed in this chapter of motion in one dimension, because the mathematical concept need to be understand, otherwise it will be difficult in future. Okay, so in the previous video I have just already told you about that how to make the derivative of a given function. Now here I'm just going to tell you about the integration. Okay, now integration means what? Integration means summation. Whenever you are adding some things, then in that case the continuous addition is known as integration. Okay, it's one of the most funniest thing in mathematics as well as in physics. This is known as an integration sign. Okay, inside that integration sign we need an operator. The operator can be, like in the derivative we have used an operator as dx. Here also the operator can be dx, it can be dy, it can be dz, anything. With respect to this operator you can integrate a function. But remember one thing, derivative and integration, they are opposite to each other. Okay, so integration of dx, this means integration of derivative of x, and I have already told you that integration is anti-derivative, right? Just the opposite of derivative. So in this case, whenever I will integrate that d of x, that d and the integration, they will cancel out and I will get simply x. Now actually there are two types of integrations are. One is the indefinite integral, another is definite integral. So in the case of indefinite integral, you are operating a function without any limit, like that we have done here. But in the case of definite integral, some limits are present, some upper limit and lower limits. Okay, now whenever you will integrate a function, it can be dx, it can be x dx. In that case you have to write down a constant which is c. Here c is actually a integrating constant. Okay, c is actually a integrating constant. I hope this thing is clear. Now in this case, in physics, maximum of the function will be of t. That means suppose the displacement will be given or the value of acceleration, velocity, these things are given to you. Okay. Now you will learn all of the things that where you have to use the integration, but you should know the basics at first. So remember one thing, the first formula of integration, that is integration of x to the power n dx, that is equals to x to the power n plus 1 divided by n plus 1 plus of c, where c is an integrating constant. Okay. Now when I have written this formula, with the help of this we can find out what will be the value of x square dx. That should be equals to x to the power of 2 plus 1 divided by 2 plus 1 plus of c, and it is equals to x cube divided by of 3 plus of c. Right? I hope this much is clear. Now if I find out the same formula and I'm just writing down in a different way, suppose t to the power n dt. Now whatever be the variable, the same operator you should have, otherwise the integration cannot be performed. Here I have written a variable of t, so that's why I'm having an operator of dt. So the formula should be t to the power of n plus 1 divided by of n plus 1 plus of c. Right? So what should be the value of t to the power of q dt? That will be equals to t to the power of 3 plus 1 divided by of 3 plus 1 plus of c. That means it is t to the power 4 divided by of 4 plus of c. Right? As I have already told you that in the case of differentiation or in the case of integration, whenever you are differentiating a function, suppose 2t square dt, you are integrating that function. So in that case, a one constant is present, 2. So the constant will be out of the integration, because in that case constants are not integratable. So that's why we'll write down 2 into integration of t square multiplied by of dt. So I will use the formula, that is t to the power of 2 plus 1 divided by of 2 plus 1 plus of c, and it will be how much? It will be 2 into t to the power of 3 divided by of 3 plus of c. That much is enough. Okay. So if you have any of the doubt up to that, you can tell me. Okay.